Hello friends, welcome back to my channel Chemistry with DB. So in my last many years of teaching hundreds of students GCSE and A levels, I have realized that most students struggle with titration calculations and they make some simple mistakes which cost them quite a lot of marks. So in this video what I am trying to do is I am just breaking down these most common mistakes that students make and I'll tell you the ways how to avoid these. So what examiners expect out of a titration question is that the students would be writing a balanced equation, then work out the moles from the given data. Then through the molar ratio, you will find out whatever is the concentration or mass or MR or whatever is needed to be, calculated over there, whatever is the unknown, and then they will apply a correct units also for this. Now, the first mistake that the students make is that they don't write a balanced equation because they are assuming that it's a 1-to-1 molar ratio. And straight away they jump into the calculation, which is wrong because the question should always start with a balanced equation. And for that, it's very important that you write correct formula. For example, if you have to write magnesium hydroxide, then you should write MgOH2 and not MgOH. Or if it's sulfuric acid, then in that case you write the correct formula of sulfuric acid. So writing the formula correctly is very, very important. The second mistake that most students make is that they assume that it's a 1-to-1 molar ratio, whereas correct molar ratio can be arrived at when you write a balanced equation. So for example, in case of calcium carbonate and hydrochloric acid, it's a 1-to-2 ratio. For sulfuric acid and sodium hydroxide, it's a 1-to-2 ratio. Sodium hydroxide 2 moles and sulfuric acid 1 mole. So that molar ratio is very, very important to get the question right. The third mistake that the students make, that when you are given the experimental titer volumes, then in that case, instead of using the two concordant titer volumes and then the mean of those, they use the rough titer volume, right? So most of the times the first reading is always going to be a rough titer. Okay, so we have to include at least two concordant titers. Concordant titers are the ones the values of which don't differ by more than 0.1. So we can see that 23.40 and 23.30, these here are the concordant titers. So you will take a mean of these. So the mean titer will be 23.35 centimeters cube. Fourth mistake is the unit errors. Concentration always has to be given as mole per dm cube. So if you are given the volume as centimeter cube, must divide by 1000. If there is something given as kilogram, then you have to convert into grams before you find out the moles. Similarly, if the data is given as milligram, then you divide by 1000 to get the data in grams. Fifth mistake that the students make is that if you made a solution of 250 centimeters cube and then you ended up using only 25. So remember that the titration has used only 1/10 of what the original volume was. So therefore, when you arrive at the number of moles, you must multiply by 10 to get the number of moles in the original 250 centimeter cube solution. Next mistake that the students make is they keep rounding at every step, right? Whenever they make a calculation, they keep rounding it. But that's so wrong, because in that case, what will happen is that your final answer will be far away from the actual answer. So you must keep full calculator values at least up to 4 decimal places, and rounding off should be done only at the end. And whatever the question is asking you, that to how many significant figures you have to give your answer, take care of that, because otherwise you would be losing one last mark in every question. Now let's look into one question, a titration question, wherein we have reacted sodium hydroxide with sulfuric acid in a titration, and we are supposed to find out the concentration of sulfuric acid. So first step is going to be writing the equation. Okay, so And after that, we see that we have got the sodium hydroxide. We can work out the number of moles of sodium hydroxide, which will be 25 multiplied by 0.04 over 1000. So that is 1 times 10 to power minus 3 moles of sodium hydroxide. Now we have the sodium hydroxide moles, so we can find out the number of moles of sulfuric acid. So which is going to be, because it's a 2 to 1 ratio, so therefore divide by 2. So number of moles of sulfuric acid is going to be 5 times 10 to power minus 4. Okay, and then in that case, because there is no dilution here, right, we just are going with the actual volumes. And then you know that the formula for concentration is number of moles divided by volume, which has to be given in dm cube. So therefore what we are going to do is taking the number of moles of sulfuric acid, 5 times 10 to power minus 4 times 1000, because volume is dm cube, and divided by 20.75, and that gives us the answer as 0.0241 moles dm minus 3. So as three significant figures, it will be 2.41 times 10 to power minus 2 moles dm minus 3. So now this question is done to the, absolutely the way the examiners would have expected, and this is going to be right. Now let's look into another question in which a monoprotic acid means 1 mole of that acid releases 1 H plus ions, 1 mole of H plus ions, and that you are reacting with sodium hydroxide. Okay, so ratio is 1 to 1, right, giving you water, neutralization reaction. So in this question, what we are going to do is, first of all, let's work out the number of moles of sodium hydroxide. So number of moles of sodium hydroxide is 0.25 multiplied by 23.50 over 1000. So we have got 5.875 times 10 to power minus 3 moles of sodium hydroxide was used. Now ratio is 1 to 1 ratio for sodium hydroxide and that monoprotic acid. So therefore the number of moles of the acid, but remember this was because there was a dilution. You made up the solution to 250 and then you used only 25 centimeter cube of that acid. So therefore number of moles of acid in 25 centimeters cube, because of the 1 to 1 ratio, is 5.875 times 10 to power minus 3 moles. So if in 25 centimeter cube it's this much, so in 250 it will be 10 times, or 5.875 times 10 to power minus 2 moles, right? So once you figured out the number of moles of the acid, monoprotic acid, now you have the mass is 13.80. So it's easy for us to work out the MR using the formula mass divided by moles. So when we do the 13.80 divided by the answer, which is 5.875 times 10 to power minus 2, then we get the answer as 234.90. So that's our answer. So as three significant figures, we can give the answer as 235. So 235 is the answer for this question, and this is how we will be taking care of everything that was required of us to be able to do this question. So I hope this video was useful, and if you like this, then please like, share and subscribe. Thanks for watching, and I look forward to see you on my next video. Bye. Take care.